Related work. The current research proposes a web mining algorithm that exploits knowledge-based semantic information to integrate text summarization and web page segmentation technologies, thus improving the overall approach effectiveness. The following sections overview the state-of-the-art in the different research areas involved: web content mining, text summarization, and web page segmentation. The section also highlights the points of novelty introduced by the present research with respect to previous works. Web mining is the use of data mining techniques to automatically discover and extract information from web documents and services. The applicative areas include resource finding, information selection, generalization, and data analysis. Incidentally, machine learning methods usually address the last two tasks. Web mining includes three main sub-areas: web content mining, web structure mining, and web usage mining. The former area covers the analysis of the contents of web resources, which in general comprise different data sources, texts, images, videos and audio. Metadata and hyperlinks are often classified as text content. It has been proved that unstructured text represents the prevailing part of web resources. This in turn motivates the large use of text mining technologies. A wide variety of works in the literature focused on text mining for web content mining. Some web content mining techniques for web search, topic extraction, and web opinion mining were explored in Liu et al. Showed that web content mining could address applicative areas such as sentiment classification, analysis and summarization of consumer reviews, template detection, and page segmentation. Web content mining tackled business applications by developing a framework for competitive intelligence. An advanced search engine supported web content categorization based on word-level summarization techniques. A web page analyzer for detecting undesired advertisement was presented in. The work described and proposed a web page recommendation system, where learning methods and collaborative filtering techniques cooperated to produce a web filter for efficient user navigation. The approach presented in this research differs from those related works in two main aspects. First, it exploits semantic-based techniques to select and rank single sentences extracted from text. Secondly, it combines summarization with web page segmentation. The proposed approach does not belong to the semantic web mining area, which refers to methodologies that address the development of specific ontologies that enrich original web page contents in a structured format. To the best of the author's knowledge, the literature provides only two works that use semantic information for web content mining. The research described and addressed personalized multimedia management systems, and use semantic, ontology-based contextual information to attain a personalized behavior in content access and retrieval. An investigation of semantic-based feature extraction for web mining is proposed in, where the WordNet semantic network supported a novel metrics for semantic similarity. A summary is a text reduced by one or more other texts, expressing important information of original texts, and no longer than half of the original texts. Actually, text summarization techniques aim to minimize the reading effort by maximizing the information density that is prompted to the reader. Summarization techniques can be categorized into two approaches. In extractive methods, summaries stem from the verbatim extraction of words or sentences, whereas abstractive methods create original summaries by using natural language generators. The works of Das et al. And Gupta et al. Provided extensive surveys on extractive summarization techniques. Several methods relied on word frequency analysis, keywords extraction, or selection of sentences according to their position in the text. More recent works use TF-IDF metrics, term frequency, inverse document frequency, graphs analysis, latent semantic analysis, machine learning techniques, and fuzzy systems. Other approaches exploited semantic processing, adopted lexicon analysis, whereas concepts extraction supported the research presented in. Abstractive summarization was addressed in, where the goal was to understand the main concepts of a document, and then to express those concepts in a natural language form. The present work actually relies on a hybrid extractive-abstractive approach. First, most informative sentences are selected by using co-occurrence of semantic domains, thus involving an extractive summarization. Then, abstractive information is produced by working out the most representative domains for every document. Website pages are designed for visual interaction, and typically include a number of visual segments conveying heterogeneous contents. Web page segmentation aims to grasp the page structure and split contents according to visual segments. This is a challenging task that brings about a considerable number of issues. Different techniques were applied to web page segmentation in the past years: PageRank, graphs exploration, rules, heuristics, text processing, image processing, machine learning, and semantic processing. Web page segmentation methods apply heuristic algorithms, and mainly rely on the document object model, DOM, tree structure that is associated to a web resource. Therefore, segmentation algorithms may not operate properly when those ancillary features are not available or when they do not reflect the actual semantic structure of the web page. Conversely, the approach presented in this lecture only relies on the processing of the textual information that can be retrieved in the web resource.